Hi, Mr. Tenzin. This is a video for our physics group project. We are from the group Forces and Motion in Amusement Park. The group consists of me, Sun, Moji, Kaopun, and Namo, and we're all from 1105. The objective of this project was to demonstrate and explore the principle of Newton's laws of motion through a miniature amusement park models, analyzing how different forces and motions interact in rides, including Viking, merry-go-round, and slide. For the inspiration of this project, we were curious to see how certain rides in amusement parks utilize the Newton's laws or laws of motion, and how these laws can be applied to real-life situations. This project aims to observe how variations in forces and mass impact motions, inertia, acceleration, and interaction forces, providing a hands-on understanding of classical mechanics in real-world applications. We wanted to know, first, how does the force applied to the pulley affect the speed of the merry-go-round, and how does this relate to Newton's third law of motion? 2. How does the weight of marble affect the size and depth of the impact it makes in the sand at the bottom of the slide? And how does this demonstrate Newton's second law of motion? And the third question being, how does Newton's first law of motion, or inertia, explain the continuous swing motion of the Viking ride, and what external forces eventually stop it? By the end of this project, we can finally understand the concept of Newton's laws of motion, how they work, as well as how these rules are applied to these 3 rides in the amusement park.
By adopting the 6 steps of scientific method to this experimental project, we were able to carry out this project smoothly. At first, we were intrigued in the possible applications of physics and motion in amusement parks. So we decided to research and create a 3D model displaying those motions found in various recreational rides commonly found in amusement parks. Our 3 main questions in this project includes: 1. How does the force applied to the pulley affect the speed of the merry-go-round? And how does this relate to the third law of motions? 2. How does the weight of marble affect the size and depth of the impact it makes in the sand at the bottom of the slide? And how does this demonstrate Newton's second law of motion? 3. How does Newton's first law of motion, inertia, explain the continuous swinging motion of the Viking ride? And what external force eventually stop it? Our hypotheses include: 1. If the Viking model swings back and forth, it remains swinging until the external force is applied to the Viking. 2. If we apply more force to turn the pulley handle, then the merry-go-round turns more according to the applied force. And 3. If a heavier marble rolls down the slide, then it creates a bigger hole in the sand. This experimental project was conducted in a span of approximately 4 weeks.
Materials. The materials we need to make this project include cardboard sheet, yarn or rope, hot glue, sand, sticks and chopsticks, beer mat board, art paper, color paper and sticker paper, plastic container, marbles, and other decorations. Procedures. Let's take a look at our Viking. There are 2 main steps to this. 1 is to make the body of the boat, and 2nd is to make the anchor. We started with cutting the cardboard box out into these pieces and glue them together with hot glue gun to make the body. Next, we cut a white paper out into a small rectangular piece and cut a red sticker paper into these strips and place them together to make the flag. Next, we glue the flag onto a small chopstick and place them onto the center of the boat. Moving on to the second part, we need to make the side part of the anchor by holding the chopsticks together to make a small X on top, and then we glue them together using hot glue gun. Do the same thing to another pair of chopsticks because we need 2 sides. Next, you place the last chopsticks on top and tie them together using yarn or rope. To complete this model, we glue 2 short ropes onto the inside of the boat and tie them on the top. And then we are done with the Viking. Our second model is the merry-go-round. The first thing we did is making the roof. We cut a yellow paper out into a shape similar to Pac-Man, decorating it with small green rectangular paper and glue a long yellow bar at the bottom. Next, we made 3 red teacups simply by gluing red sticker paper onto small plastic cups. Then, we made the base of the merry-go-round by cutting a cardboard sheet into 1 big circle and 1 rectangular bar. Covered them with yellow paper sticker for better aesthetic. After this, we cut a cardboard into 2 smaller circles and 1 smaller bar. Of course, sticking the different parts together as well. Also, don't forget to poke a hole in the middle, right there, because we need to insert the stick at the end. For part 2, we repeat what we just did in the previous step, but this time glue the top of it with a red sticker paper. Place 1 stick in the middle and glue another onto the side. 1 wheel allows the pulley to rotate and 1 is the holder. Finally, we combine the first part and the second part together and tied them with rope. And here we are, our merry-go-round is done. Moving on to the last element we got in our amusement park, the slide. First, we drew these shapes onto a cardboard sheet and cut them out according to the dash line. After we got all out, we just glue it with a hot glue gun. Glue the slides together first and then glue the structure the second. Finish this up by gluing everything onto a large beer mat board and fill a plastic container with sand.
The first problem we encountered was during the first week of the project, when Kaopun had to travel to a competition in India. This made it challenging for us to divide the task evenly and ensure steady progress. To address this, we adjust our timeline and focus on completing the initial stages of the project, such as brainstorming and gathering materials. We also maintain regular communication to keep everyone updated and on track. Another challenge arose during the week after Week Without Walls, when Sun and Namo got COVID-19. Our materials were in Sun's locker, so for the first day, we were only able to do the structure of the Viking. And then the second day, Sun's mom dropped off Sun's locker key at the front desk and we went to grab it and get the materials from Sun's locker and were able to finish the merry-go-round and the Viking. Despite initial challenges, our group maintained effective communication throughout the project. When Kaopun was away, we adjusted responsibilities and kept each other updated, ensuring the project stayed on track. We overcame several technical challenges, such as reducing friction in the Viking ride's pivot and fine-tuning the pulley system for the merry-go-round. These efforts helped us create functional models that effectively demonstrated the intended motions. We also successfully applied Newton's law of motion to our models and clearly demonstrated these concepts through the merry-go-round, Viking rides, and the marble slide. Our ability to connect physics principles to real-world scenarios like amusement park rides was a highlight of the project. While we managed to complete the project on time, our progress was uneven due to the unexpected events like Kaopun's competition and also the COVID-19 events. Next time, we will create a more detailed timeline with plans to handle unforeseen delays. We encountered several technical issues during the construction phase that could have been avoided with more testing. So next time, we will allocate additional time for prototyping and testing to identify potential problems earlier. Overall, this project was a valuable learning experience. We are proud of what we accomplished and look forward to applying this lesson to future experience. Our Viking demonstrates Newton's first law of motion, also known as the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. When the Viking ride is set into motion, it swings back and forth due to the initial force applied by our force. Once in motion, inertia causes the ride to continue swinging because objects tend to maintain their state of motion unless an external force acts on them. However, there are external forces that stop it. First is the air resistance. As the ride swings, air exerts a resistive force on the moving surface, gradually reducing its speed. The second external force is gravity. While gravity initially helps sustain the swinging motion by converting potential energy into kinetic energy, it also contributes to the ride's eventually stop by pulling it towards a resting position at the bottom of the swing. These external forces cause the Viking ride to lose energy gradually, eventually bringing it to a halt. And without this force, the ride would theoretically swing forever.
Our merry-go-round demonstrates Newton's third law. For every action force in nature, there is an equal and opposite reaction. As you can see from our model, when the pulley is turned in a circular motion, the applied force will cause the merry-go-round to rotate in a circular motion as well. The forces here are equal in magnitude, but opposite in direction, and they will always act on different objects.
The slide model displays Newton's second law of motion. Force equals mass of the object times acceleration. The heavier an object is, the larger the magnitude becomes. Meaning, if a heavier marble is released at equal distance as the lighter marble, the net force of the heavier marble is larger than that of the lighter one. As shown in the demonstration video, when the heavier marble is dropped, it creates a deeper and larger hole compared to the lighter one.
This physics project contributes to the SLOs in 3 ways. The first one being articulate communicators. Students were required to communicate articulately since they were assigned to work in groups. Therefore, they needed to be able to communicate with each other clearly and understandably. The second one is innovative thinkers. Since students were required to create models in order to prove the physics laws of motion, they must be creative with the idea and the concept of the project, and also be resourceful when it comes to the materials being used in the project. The third one is strategic learners. Because students were required to prove certain rules and laws of physics through the project, they must use their knowledge and apply it into the models in order to prove that physics also occur in real-life situations around us. Moreover, they might face some difficulties while doing the project. So it is a great opportunity for them to learn how to solve problems while doing the work. It also brings them together as they had to work together in order to find the solution.